Okay. 3.2e. We just get a little deeper into this. We might work with a few more fractions and things like that. But we're still doing the same thing, working until the left side meets the right side. Looking at the left side, where should we start? Factor the top. What can we factor on the top? Take out a cosine squared of x, and then we're left with cosine squared of x plus sine squared of x all over sine of x. Now, what do we see on our left side that we can simplify? Cosine squared of x plus sine squared of x equals 1. So I'm left with cosine squared of x times 1 over sine of x, basically. But how is that going to equal cosine of x cotangent of x? So now we got to see, well, I have cosine squared here, and I have a cosine here. So I need to split these cosine squareds up into cosine and cosine, right? So I'll split it up into cosine of x times cosine of x, and then I'll leave a sine of x down here. So this is really cosine of x over 1 times cosine of x over sine of x. Because we multiply cosine of x times cosine of x, we get cosine squared of x, and 1 times sine of x is sine of x. And cosine over sine is cotangent. And we're done. The next one, 1 minus cosecant of x over sine of x equals cotangent squared of x. Negative cotangent squared of x, that is. Now, this is where you have to think a little bit outside of the box. Okay? So, normally I change cosecant into what? 1 over sine. So I'd have 1 over sine of x over sine of x. But I see I have a cotangent squared here. And I know from my Pythagorean identities, we have something with a cotangent squared and a 1 plus. And so 1 plus cotangent squared equals cosecant squared. So if I have a cotangent squared and I have a cosecant here, it'd be nice to make this into a cosecant squared. So then that would fit into that Pythagorean identity, right? So you got to think ahead a little bit. So instead of changing cosecant, what should we change? Sine into what? So 1 minus cosecant of x over 1 over cosecant of x equals negative cotangent squared of x. I have a complex fraction there. How do I get rid of a complex fraction? Multiply by the denominator of the denominator. So these cancel, and I get 1 minus cosecant squared of x equals negative cotangent squared of x. And I know 1 plus cotangent squared equals cosecant squared. So if I subtract cotangent from each side, subtract cosecant of each side, I know that 1 minus cosecant squared equals negative cotangent squared. So at this point, I can just put negative cotangent squared equals negative cotangent squared. I'm good, because I have my Pythagorean identity to back me up. Tangent of x, cosine of x minus sine squared of x, cosecant of x equals 0. Right now, this looks really complicated. It's actually a very simple subtraction problem.
Isn't it just like a positive one minus a negative one?
Basically, the positive 1 minus another positive 1 equals 0. 1 minus 1 equals 0. But it's not quite that. Okay. So, if I have a bunch of different things, let's change them into sines and cosines. So tangent is cosine of x is cosine of x, so it's cosine of x over 1. This is sine squared of x over 1. And cosecant of x is what? 1 over sine of x. Okay, so I can do some canceling here, right? I can cancel a cosine with a cosine. And one of the sines up here with the sign down here. So I get sine of x minus sine of x equals 0. So 0 equals 0. Are we good? $43 through $50 all, page 172.